So it's very exciting for me to first see everything that's coming out of Norway and all the reproducibility clubs and all the activities that you have. I admit to being a little bit jealous. I wish we could have something like this in Hong Kong. Unfortunately, so far, it's kind of like a one person operation. So there's a certain institutional environment in Hong Kong and HKU. And I think the purpose of me sharing this with you is to show you what's possible when you have an idea and you want to do something about it, despite perhaps the institution or the environment not being so inclined to do that. So I think with your environment, you can do wonders. You can take whatever it is that we do and take it a few steps further. So I'm actually looking forward to staying afterwards and seeing the kind of discussions that you have. And I would be happy to do whatever I can in order to support you to, at the very least, do what it is that we're doing, and then perhaps take it to other exciting directions and maybe make this your own in some way. So in the spirit of open science, of course, all the slides are downloadable. So you can scan the barcode, you can go on this link over here and take this. There are going to be quite a few hidden slides and lots of links that later on you can just click and look into further information. I will go through things rather quickly. There is a lot going on, and I can imagine you having all kinds of questions. So collect the questions that we can discuss this. And of course, if you afterwards want to follow up, I'd be happy to talk to you about any of the activities of what we're doing, and of course, how you can join any of those. So if you see an opportunity, you see something that's interesting for you, everything that we do has an opportunity for you to join us and do something together. And we are very excited about having as many people as possible. And right now, there are already some representatives in Norway, and I'm hoping at the end of the month to also come in person and do something exciting together as a workshop. So that's something to look forward to. And I should also say that all the talks that I have, hopefully also this one, are shared on the Open Science Framework and on YouTube. So if you're missing something, you want to go revisit this, or you want to share this with others, then you could. Another thing that I want to make clear, that open science is not just about research, but it's also, in my view, about education. So everything that I've ever taught, and most of the things that my students have done, aside from grades, is shared on the Open Science Framework. So if you want to see how we did stuff, you can go, and from the syllabi all the way to all the materials, everything, the slides, handouts, you can go and take this, plus all the, since the pandemic, the hybrid mode and Zoom, everything is also recorded and shared on YouTube, so you can go and watch some of that. So I'll start from the very obvious. I like it that all of you know what open science is, and I don't have to state the obvious, but I do want us to kind of congratulate ourselves a little bit. So after a few years of having to go against the stream and having to try and talk to people why they would need open science, I think it's a big achievement. Finally, 2022, UNESCO comes together and has this declaration with a global call for best practices of open science. When I saw this, I was just exhilarated. So no longer the question is, do we need open science? But it's happening. It's in place. The question is how, and what can we do to support this? So I think for the first time in a long time, people come to me and ask me, okay, so we need to do this thing. How best to do this? So I think it's an exciting time for us after many years of struggles with the scientific community. And more recently, just now, May 20, 2023, the G7 coming together and saying that they will promote open science, everything from publicly funded research, all the outputs, research data, scholarly publication with the FAIR principle. So well done. I'm very glad to see this in the Science and Technology Declaration. I'll just give you my overview, and this is a slide that I almost have in every presentation. Sometimes when I go and I talk about open science, there's all sorts of a little bit of frustrations or a little bit of open questions about what does it mean? How is it going to change my career? Should I do anything about this? And then not rare that we get a lot of pushback, especially from the higher you go up, the more senior, the more established, the more bureaucracy you have, the more questions people have. And I think at the beginning there was also many questions about whether this is there a real reason to change? Why change something that is functioning? There is electricity, planes are flying. So what do you mean we need to change science? So this is my view of the general state of science right now. I am convinced that there is a need for, at very least, self-reflection, reassessment, and constant improvement. I think it's one of the core principles of science for us to kind of thrive to try and implement improvement in science. So sometimes when people talk about climate change, so they talk about things that we all want. We want livable cities, we want clean water and air, we want healthy children. And then somebody comes up and says, but what if this is all a big hoax and we create a better world for nothing? So my view with this open science is quite the same. So we're talking about all sorts of really good things for science that improve the rigor, the quality of our outputs. So increased transparency, doing replications, open access, preventing p-hacking, questionable research practices. So what if this is a big hoax and we create a better science for nothing? I'm just in the view that this is part of science. Let's create a better science and move with that. In my own personal journey, I really had to make some big decisions in my career, because in my PhD, this was not taken for granted. Actually, I came very late to the open science direction. I was actually not in psychology. I was based in a business school in a management department, trying to make sense of the methodology and the way that they approach science, and this very strong emphasis on theory and storytelling, and a very short, brief, non-transparent method section. So when I did my postdocs, which were in a psychology department, I sat with myself for a year. It took me a year to sit down and think, okay, so I have some sunk costs. I've invested in a PhD, done all sorts of things, been trained a certain way, but I feel like something is happening and I need to readjust. So I just sat down with myself and wrote down the principles that I think I would like to aspire to. And it's very simple now. Now it's almost taken for granted. But back in the day, it seemed like almost a risk. So investing in trying to understand how to do pre-registrations, now taken for granted, 2016, 17, it really wasn't. Replications, nobody was doing this aside from the mega collaborations like many labs and open science collaboration. Full transparency, I wanted to do that. I wanted to do pre-registrations, but I really did not know how to do this. So having to sit down and first know that this is what I want to do, and then wanting to implement this in my own work was a big step to take, and quite risky in the stage that I was in a postdoc. So is this going to threaten my chances of getting a tenure track position? I was worried about all sorts of things, but this felt really important. This felt like something that I should do. And at the center of all of this, I decided that no longer what I've been trained on, of just sitting with myself in a room, writing a paper a year by myself, it needs, in order to tackle all of these issues, we do need collaboration and community. So when we talk about education, when we talk about research, I feel like collaboration and community is at the core of this. So we need to think very carefully how we can leverage what it is that we do in education research in order to involve the community and contribute to the community. So our aim at the end is to do open science, to do better science, more rigorous science, more transparent science. And the way to do this, I thought back in my postdoc days, is that when I get a tenure track position, I want to try and do this integration of education, research, and community. Now, this is how I've been trained basically my whole life. So this is the traditional model of a professor standing in front of a room with a PowerPoint slide or whatever that they have, where students are very passive. So they're over there in the back and they're listening to a professor with a very traditional look saying, my truth is, so follow me. The textbook says that this is what social psychology is, or this is what judgment and decision making is. But a few inspirations came along the way. The most recent of them that I think really allowed me to get some good feedback on my general approach was this book by Adam Grant. It has all sorts of really nice things, but I really like this chapter 9 book, says rewriting the textbook. So one of the first things that I had to decide in my entrance to University of Hong Kong is I got the textbooks and the slides from the previous instructors, and they were told, okay, so this is what you need to teach. This is what we've been teaching for a long time. And I decided to put all of this aside. Given everything that's happening in science and social psychology, there was almost in every page, there was something that I felt uncomfortable with, and that I doubted myself whether this solid, replicates, generalizable to people, let's say in Hong Kong, all sorts of issues. But much more important than this, I really felt like instead of me telling them this is the truth when I don't know that this is the truth, I should invite them to question the textbook and maybe revisit some of these classics together. So there's all these principles that I laid out that I really believe in, training the students to have a scientist mindset, with a lot of humility, saying sometimes I'm the professor, I'm the instructor, but I really don't know. And actually, there's a lot that I can learn from you. So students can inform me. Some of the things that you students do, you do much better than I do. Coding, it takes me a much longer time to catch up on things, but just the way that you look for information, you integrate information, the kind of questions that you have, that I've been brainwashed to be biased a certain way of how science should be, the questions really help me, inform me about science. So together we can have kind of like a synergy where we're learning by doing, and we're both making progress in order to make science better and make sense of what science says. And in the process, I think it's important to understand that confusion is natural, uncertainty is natural. This is science, and science is very messy and complicated. And to tell them that everything is just this clean science, and take it for granted, or take my word for it, this is what the solution is. I think that's no longer tenable. It's not something that we can really give convincingly to students. I don't see how anybody, even with 20, 30 years in our social psychology, judgment, decision making, I don't know if anybody can really say that they're experts and they know anything 100% for certain. So I like this involvement. And in Maastricht University, where I did my postdoc, there was this system called problem-based learning. So rather than this old model, having students work together in teams in order to tackle a problem. So rather than telling them, okay, here's the solution, multiple choice exam on this solution that I told you, you present them with a problem, and you guide them through this, or you give them a certain structure for them to be able to implement that kind of process. And I needed to think long and hard what I want this problem to be. And for me, I'll talk about a few of these kinds of problems, but there were big components of what I thought is part of the scientific process that students can tackle during the semester. General principles for open science in the classroom. I really wanted this to be student-led, so rather than everything depending on me and everything is I give to them, it would be all of us working together, a little bit like hackathons that we have in conferences like SIPS. I'm part of the process, but I don't have anything that's like higher hierarchy. I try and guide best I can, but they all help one another. They do actual science. I wanted them to have the ability to trust that they are capable of getting to a publishable, high standard science that would be part of the discourse, contribute to part of the academic community. We would use the latest tools and trends as I perceive them to be in psychological science, implementing open science. And I really wanted them to experience the scientific process. And that means we do peer review in science. We send this to journals, then we have our colleagues go through this. So I really wanted the students to understand what peer review feels like, what it means to give review and what it means to receive a review, what it means to share everything very broadly in the community. So everything that we do, I go on Twitter and I invite others to come and look at the Google Docs. So this really is no longer me and the students, just us together with each other, but us really being involved in the larger community. And no more books with problematic findings. We really need to find a way to update our books and have them, continuously updated with the latest finding. And there's no more like my instructor truth. It's more like emphasis on the process rather than the outcomes. And open science, of course, all the principles. I think the most important thing that is a little bit difficult for students, and at the beginning there was a little bit of pushback, and we really needed to negotiate this together and come to some conclusion that not only that everything that I do, like slides and handouts, is shared, but everything we do, even the students, even their classwork, is shared on the open science framework. So on the one side, it's really intimidating. Is everybody going to see that I don't know what I'm doing, that I make errors, that I make mistakes? And I wanted to give them the confidence that I also make mistakes, and actually sharing this with everybody has the ability to help you find mistakes and help you improve. And also, I think at the end, it brought to higher accountability. So they were actually excited about this and getting feedback from the community and really engaging in order to learn and improve themselves. So if you're learning focused, sharing everything is a really good way to do this, despite all the lack of confidence that maybe you're not so good. So the only way to do this is put yourself out there and learn from that. So no hierarchy, everybody is working together, more emphasis on rigor and accuracy rather than novelty. So I understand we have a workshop, I'll talk on this later today, but also when I did my PhD, it was all this moderation, mediation, multi-level, it's very advanced statistics and all that. I really try to emphasize simplicity with them. So a little bit about what this looks like. So seems like a very broad kind of vision for what we want to do with students, but how to actually implement this kind of thing. What does it mean to engage with the academic community and to incorporate teaching and mentoring with the collaborative science, open meta science? So I'll give you three components and an added twist at the end. So the three components are, we did a lot of replications and extensions. And now I think this is like the core of the core team. This is what we are most well known for. And there's lots of outputs coming out from that. But actually, this is just like part of what happens throughout the semester. And it starts with science assessments. So we actually revisit some of the classics, many labs collaborations, whoever shared, and we can look at the data and what they've done. But increasingly, we're moving into science assessments of actually what we've done. So every students look at what the students from previous years have done, and then they can learn from that in order to inform them whether they should do the replications and extensions. And through that, we are able to do a lot of community resources, templates, guides, all sorts of other things that we are working with the community in order to help the students do better, but also the students help the community. So we all contribute in order to have guides that I feel that should be out there in science, but we could not find a good solution for it. And at the end, I'll talk a little bit about what real life impact is beyond the contributing to the scientific community. So this is the core team. This is our model of integrating education, research, and community. And I wanted to find a way to support not only the students that are working with me in my courses, but generally early career researchers around the world that are doing open science. So I think we really need to think very carefully about how we keep those who are taking the risk in implementing open science. How do we make sure that they're not kicked out of the system? Because right now the system is aligned a certain way that does not emphasize open science. So I wanted to find a way to do that. I also wanted to try and implement all the best practices. And additional benefits is if we have some kind of systematic process, then we can perhaps look at an entire literature and then try to gain some meta science perspective. So for me, one of the things that I decided in my postdoc is that I'm going to put aside everything that I've done before. So I've done all sorts of things in psychology and management, and I'm going to focus on one domain that I thought has the highest chances, the best likelihood, in my view, for having high replicability, reproducibility, and where I can implement and build on that. And for me, that was judgment decision making. Based on just my experiences in the classroom, that when I run these classic experiments, let's say framing effect, when I run this in the Netherlands, where I did my postdoc, in the US, where I did my postdoc, where in Hong Kong, where I grew up, in Israel, it seems like these things replicate quite well in the classroom. But these were intuitions that I really needed to test. So I just want to show you the scale of where we are right now. So we have about 40 early career researchers from around the world that have joined us in order to take the lead over some of the projects by the students. We have about 365 students, undergraduates, that went through my courses. I think this is last year, so it needs to be updated. But all of these courses going, everybody that took the courses with me is part of the collaboration and is a co-author on whatever comes out from that course. And then I have guided thesis students, about half of them masters, about half of them undergraduates, MSc and undergraduates, where we do a guided thesis together a certain way. And we've improved with the complexity and with transparency and rigor almost every year. And I'll show you a little bit about what that looks like. What have we completed? And I think this is really a testament to what's possible with students. If we work with students, this is what's possible to do within 4 or 5 years in our courses. So we've completed with data collection about 80 pre-registered studies, replications, and extensions in the classic literature of judgment decision making and social psychology. I have about 40 registered reports. So I think our lab is really trying all the best practices in registered reports and taking big risk where people are still trying to figure out what registered reports are. So more and more we're moving into a system where finally we're getting the reviewers that support open science and understand registered reports. But through that, we're both learning about registered reports and helping the community improve on that. The thing that I think I'm most proud of is these 20 collaborative open science templates and guides. I'll show you a little bit what that looks like. And the number of assessments is around 36. So I'll start from the biggest, I think, achievement, which is the community resources. So we built a lot of resources. So at the beginning, it was a question of how do we take a second-year undergraduate that has barely ran a t-test, in an introduction to statistics methods in their first year, how do we take somebody and within one semester have them write a high-quality scientific output of replication and extension? It almost seemed impossible at the beginning. Rather than me having to write all these guides and then, maybe 2 pages here, 2 pages there, what I did was set a lot of Google Docs. So Google Doc, for example, for how to run a pre-registered replication extension, how to do Jamovi and JASP, how to write our Markdown, how to calculate effect sizes and confidence intervals, how to do a power analysis. So I set this up as a Google Doc, and I asked my teaching assistants that every question that is asked, we would just put this in the guide and send a link to that guide. When a student asked me, what should I do in this case, I would tell them, please go search the whatever you can find on Google resources, Google Scholar, and see what solutions you have, put it in there, and then I will update this on that. So we would have kind of like a discussion where a student has an initial solution that they found to some issue, other students can come in and also contribute, and then we have like a whole discussion. And then at the end, I finalize this in what I think is the best solution. So from something that would, I don't know, be 2 to 5 pages, some of these guides are like hundreds of pages long because everybody contributed. And at some point, they were good enough for me to share this with the community. And then I would invite everybody, go on Twitter and say, we have this guide. Anybody want to contribute? So even you, if you feel that you have something to contribute, to add, to adjust, to correct, in these guides, you can come in, you can add whatever it is, you can add your contribution, state your name, what it is that you added, and then you're a co-author. So some of them already have preprints, and all the early career researchers that contributed are listed as co-authors. So this is community effort. This is how community should advance science. So very, very high quality templates that you can just take and use as is. We have a lot of experience with Qualtrics, with MTurk. So just go and check these out. I think they'll be very valuable for you. And this is also an opportunity for us to collaborate together if you can see some way for you to improve what we've done or add to it. Moving on to the replications and extensions, there's a whole discussion in academic community about what replications actually provide. And I think sometimes replications are kind of underappreciated because some people say, okay, replication crisis, but what about let's say measurement, or what about theory? And to me, replications actually target all of that. So if you do replications a certain way, it can really address the theory crisis, and it can address the measurement crisis. And many of the replications that we've done actually have extensions that directly tap into answering some of those. So for example, with theory, some of the classics that we visit don't have a clear theory and predictions. And we are the ones that say, okay, based on our understanding, these are the predictions, this is the falsifiable theory, this is what should happen in order for us to gain an understanding on how to improve this theory. So it starts from verification and reproducibility. Can we really revive these old materials, these lost materials? Looking, of course, at replicability to increase our confidence that the results really hold and that they have some kind of over time that they are still there, they're still in effect, and we can find it with different samples in a different place in the world, and we get a better estimation of the effect size using more rigorous open science methods. We can also improve on measurements. So many times we added DVs, so not only just the original DV, but we also added other DVs that look at the scale in a different way, and then we compared whether measuring this the old school way, just a replication, or measuring this a different way actually improves the kind of insights that we can gain from that. Generalizability, of course, is a main thing. So we conducted many both in Hong Kong and in Amazon Mechanical Turk Cloud Research online, sometimes prolific in the UK. And more recently, some of the teams around the world are taking the replications that we've done and translating this to other languages. So for example, just recently, this week, I think, Brazilian team took some of our replications, translated this to Portuguese, and ran this in Brazil. So you can also test other things in replications theory, just mentioned, and then to reignite lost interest. So some of the classics kind of like had a peak back in the 70s, 80s, 90s, and then disappeared. So I think there's lots of insights that we can gain just revisiting those and showing new angle to that and the relevance for today. Lots of things that I like about replications and extensions for education. So not only does this contribute to science, but we can learn a lot from that. And I like the systematic, structured way that students can just follow step by step, so we can show them how to do application. They don't need to start on their own identifying, theoretical gap or theoretical contribution. It's very, very difficult. Even for me, I don't still know what is a theoretical contribution. It seems very subjective, but with a replication, you at the very least know, okay, so here I'm following what it is that's been done, and then I'm adding my own twist to it based on the follow-up literature. I also feel like we are making the best use of what's been done before. So if there are materials, why not just build on tested materials, something that's already out there, rather than reinventing the wheel all over again. It also helps you to adopt a critical mindset. So just instead of following everything in the textbook, just run the thing in the textbook and then see if what it is that you've been told actually really works when you do it, when you conduct the study. And everything is a lot more measurable and clear. I also like it that when you do a replication extension, this is especially for a thesis project, rather than just investing a year, and let's say something does not work, and you think that you're a failure because you haven't done something well. But a replication extension really allows you to tackle all the frustrations in that, because if both of them fail, if both a replication and extension fail, then it's not just you with your extension. Perhaps the literature that you built on was not solid enough. If the replication succeeded and the extension didn't, okay, so maybe your new insight did not have any success in improving the literature. You can also gain something from knowing that something does not work, but at the very least, you contributed in saying, okay, but the foundations, the fundamental phenomena really exists. So replication extension, this separation really allows you to have a better structure and learn more from that. Also to things that we implemented, so we do everything on Slack and Teams, and we link to Google Docs rather than emails, and we have a lot of checks and balances. So for example, when we have a replication target, we have two teams of two students working independently, and then they peer review each other. So a lot of checks and balances, they can look at somebody else's work and improve their own work. Then the teaching assistants come in, then I come in, and then I go on Twitter and I ask the community to come in and have a look at this. And then finally, the early career researchers come in and take the lead over this. And then we submit this to journals. So a lot of checks and balances. So even if you say, maybe we shouldn't trust undergraduates because they only ran a t-test, in their first year, perhaps they've made a mistake. We have many opportunities for us to find these mistakes. And I think at the end, the undergraduates will really surprise you with the kind of the level of science that they're capable of achieving. But it's good to have a confirmation of that. So you don't have to just trust it. You will see this in the process. This is very broadly how we did this. So we have these two general directions. So we have the first 2 years, we did this actually with data collection. So we start from a Qualtrics survey. So they start to analyze the article, see how the article did all sorts of things, transfer this into the Qualtrics kind of survey design. Then Qualtrics has a very nice feature that I think most people are unaware of or don't use very often, which I think is absolutely brilliant. You can generate random data sets with random noise data, and you can write your data analysis code based on that. So at the beginning it was Jamovi, increasingly moving into R. And after you have these two things, that you know what the survey looks like, and then you have the data analysis code, you write the pre-registration, which is basically like a manuscript with the results section being the simulated data analysis. Then we get the peer review, so the two teams peer reviewing one another. Then we have external feedback from the Twitter community, and then they have 1 week to revise. I do within 2 weeks of sleepless nights all the pre-registrations and the data collection. And then finally, once again, I give them data sets, working independently, peer reviewing each other, other people come in. So we have about 80 of these completed APA-style submission-ready manuscripts over here. So ideally, we should be able to submit these, but we don't. This is where we invite you, especially if you're an early career researcher, we would love to have you come in. So you take the lead, you verify what the students have done, you add your own insights, perhaps if you want to add, I don't know, Bayesian analysis or whatever it is that you feel is needed in order to make this stronger. And then we submit this together to the journal. So you as the lead author, the students as shared first author in a note, and then the teaching assistants, and then me at the end. We've increasingly moved in the last 2 years towards register reports. So rather than all this intensity of doing data collection, we just want to make sure that we're getting the stage 1 right. So we're getting the pre-registration right. So everything that we've done in the first stage, we write this up with a little bit of a pre-test, and we send that to the journal in order to get some community feedback, not just on Twitter, but from experts in our field that are recruited by editors. So at this point, usually when I present this, people ask, okay, so it's great that you've done these kinds of research projects with the students. It's a really nice educational exercise, but is there real value in this? Can early career researchers and students really have a contribution to science? Can they do high quality science? Does it have a real impact? Can you contribute to the community? So I wanted to show you what's possible. In the first 2 years, I couldn't show anything because it took a while for us to kind of like get this going. But my answer is definitely yes. And I think our proof of concept is really should serve as an inspiration. So you can go to your university and say, look at what the students at University of Hong Kong have been able to achieve. So 2021 was like the first year where this started to come out. And you can see that all the undergraduates are actually underlined over here. So they're shared co-author with the early career researcher. So all these early career researchers that joined us in our team with a very long list of, especially if it's a second year undergraduate course, so a lot of groups of like 5 or 6, all these followed by the teaching assistants, and then me following at the end. And of course, everything is shared, open science. And we were able to, very surprising for me, to get this into some journals that I was never expecting, like Journal of Economic Psychology. Never thought this would happen. Some of the considered reputable journals in social psychology. And then once this happened, at the beginning, I really needed to motivate the students, telling them, you know, we'll submit this, there are going to be some preprints. I think once the students saw that there's some publications in this and they can add this to their CV, this might help them in their either industry or academia, they got really excited about that. And they also really like the fact that they get to learn from and collaborate with their early career researchers. So we've got a few, back then there were early career researchers, some of them are already associate professors. So it's nice to see how, like, over time, the students and the early career researchers have been able to work together. So 2022, it again, 2023, doing quite well. So overall, it seems like this model is really working. So I like all of that, but the thing that I'm really proud of is what we've done with the thesis students. And I think 2 years ago was the decision that I really just want to do register reports with students. So there's this new initiative, if you're not familiar with this, peer community in register reports is a revolution. And I decided all of my guided thesis students within the 1 year thesis are going to submit to peer community in register reports. I'll just very briefly tell you what are the added values, why is this register reports 2.0, and how this helps us. So one of the biggest questions was, can I do within 1 year a registered report? Because traditionally you write a stage one, you submit this to the journal, takes 4 months for them to come back, then it takes you a month to revise, then you submit this again, another four months, and then already the academic year is over and you've lost the chance to start data collection and for them to integrate this in their thesis. But a scheduled review is a guarantee that they will give you a peer review within 2 weeks. So if you plan this in advance, 6 weeks in advance, you tell them in 6 weeks, I'm going to give you a submission. And this is the snapshot, a 1-page snapshot. Everybody aligns to this. We work on this 6 weeks. We make sure that everything is ready. They recruit the reviewers. And then on a certain date, everybody knows that they need to, we submit on our side. They have 1 week to review, then 1 week for the recommender editor. So really unbelievable. I can't believe that it took us this long to figure out how to do peer review in a timely manner. So 2 weeks, and they've lived up to that. And at the end, it's not that you're submitting to a specific journal, you're submitting to a community. And once you get the in-principle acceptance, then you can decide which of 30, I think there's 30 of friendly journals, and then another, I don't know, 10 of interested, that you can decide which journal you want to go to. So rather than first I submitted this journal, get rejected, then I submitted that journal, get rejected, there's no risk in this. You just work with the community, and all of them are open science trained and know what registered reports are. So all sorts of amazing benefits, and this is how I implemented this. In addition, and I really recommend that you do this, it was a big question of how to get the university to fund this. So I told them, and it was to explain what registered reports are to a university like University of Hong Kong is very difficult. It almost seems inconceivable. What do you mean you have an in-principle acceptance before data collection? How is this possible? So I told them, if I give you an in-principle acceptance and I can guarantee that this will be published in a journal, will you fund the undergraduate research? So they said, yes, for sure. If there's a publication behind it, we'll give $1,000 for 30 of the students that would do register reports with in-principle for stage one. So this has made my life so much easier because, to be honest, I was not able to get any funding from the research people, but seems like the teaching folks are very excited about students being able to publish in journals as part of their thesis process. So this is just very broadly what things look like. So it's more me and the students together working against the peer community in registered reports. So this is working quite well. We've finished with stage 2 already, like 3 of them. 2 are in collaborative psychology. 1 we're still trying to determine. We have a lot of in-principle acceptances. So all the students from like last year, now we're in the stage 2 review. And I think all of them will finally be we finished. And then we have a bunch from this year, all this revise and resubmit that the students have done. So it's going really well. We've completed like 23 of these. So that's kind of exciting. And at the end, we also did some science assessments. And I think this is kind of like a demonstration that, let's say that you're not sure if you can really do replications and extensions. You're not sure if you can get the funding for it. It seems like too much work. At the very least, I think what's possible for all of us to do is science assessments. So this means like a systematic check of what's actually happening in the literature, and the students can learn so much from that, actually looking, having hands-on interaction with the materials, with the statistics, looking at what top publications have done in our literature. So in 2019 was the first time that I ran this, and I ran this on the many labs and the open science collaboration. So I asked the students, please go and have a look and try to run their R code and try to see what the Qualtrics is, or try to find all sorts of ways to improve on this, see what we can learn, both the good and the bad. So we have a template, and this is the template over here at the bottom. So you can take that template, and students are very good at just like following this thing. Once I went on Twitter and I shared this, people were like, it's great that you're revisiting the work that was done by many labs, but why are you just looking at others? Why are you not looking at yourself as well? So I said, yeah, good point. I really want us to make sure that our publications, that the stuff that I've done with guided thesis students and in the courses, is solid. So we started to run back 1 year. So 2020, they looked at the reports from 2019, or all the publications that we've had. And it was a really good exercise and very humbling. Even though we have checks and balances and we have all, you know, the early career researchers in the journal and the Twitter community and all this, there are issues, and they were able to catch this sometimes at the very critical stage, just before we were, I think one of them was already with an acceptance, but not yet with the print. So we were able to catch like at least one error in order to make sure that this is more solid. So assessments are really a humbling experience, and the students really feel this is important because they're looking at something that has real relevance. Just one case study, for example, one of the assessments is part of the replication process. So first you do an assessment, then you do a replication. They basically ran a stat check on one of the replication targets. And the interesting thing is that the replications were actually successful, but the stats in the original, at least with one of the studies, didn't make a lot of sense. And when we submitted this to the journal, we said there are some issues with the stats, so please publish these replications because it's important for the community to know. And what the journal did, Psychological Science, is that they rejected the replications, but they said, okay, we'll follow up with an expression of concern regarding the stats. So the original author and the editor of Psychological Science went out and said, a team of students in my courses found these. There's all sorts of issues for us to discuss because this was already on PubPeer. Later, we discovered that this was on PubPeer. But generally, there's something very important about having students engage with the community. If you go on my website, I also increasingly see the value on really motivating not just the students, but everybody in the community to check me and replicate me, because I really am very scared that there's some issues in there. I'm human. I have weaknesses. We do, even with all the checks and balances. So I invite people, I will pay you $5 for a minor mistake, $50 for a major mistake, and I will give you credit for it. And when I told this to the students, not only are you doing assessments for your grade, but I will also pay you cash. The students were very excited about this. I also give them the opportunity to either take this for themselves, or if they donate this to charity, I will match it. And they've decided to match it. So actually this at the end was, I think that semester they found mistake. One was a major one just before we submitted this to a journal. So that was, I am so grateful for this. And I really am glad to see this, and I would like to see more people do this pledge of check me, replicate me. But you can integrate this in your courses in order to check your own work, or colleagues in the department, whoever wants their work to be checked. The students can help with that. There's all sorts of ways to motivate this. See how we are? Okay. So I guess we should wrap up, but I just want to tell you that there's testimonials as part of the open science direction. I also share my evaluations. I think it's really important for students to see the good and the bad. So I think if you want to know how students feel about this, some feel that this is completely unreasonable workload. And I agree, this is very different from other classes. You should take this into consideration and really think this through. But I think also students are very excited about this. I would say about 60–70% of them are really excited about having a contribution to the scientific community and having a hands-on experience. So when they go into industry and academia, they can really implement some of the things that they've learned. We have talks on YouTube that you can click on these links with some of the students I have published. Actually, Nadia here also both took the undergraduate course with me and then decided to do a thesis with me. So 2 papers came out of that, Cora, an MSc student. Then we have some of the early career researchers writing in psychology today. So we have like a column where people can contribute. Max did a psychology today and a talk. So really inspiring for me to hear and see from these early career researchers. Finally, very briefly, I will touch on real life impact, which is what I've done in the last year. So one of the things in the pandemic that I realized is that maybe we should have more impact on the community. How to do this? I try to integrate a little bit of the effective altruism kind of perspective. I know this is like a controversial title and some people see this in different ways, but at the very least, I wanted to embed psychological science impact in the courses to allow students to feel that what they're doing is just not just like, replications, extensions, but also that this leads to some impact at the end. So you can go and see the revamped course from last year. There's all sorts of things about how we can do more good and how we can do good better. Also all sorts of interventions in judgment decision making. What can we do to leverage, let's say, nudges? Is a nudge a good thing to implement? To what extent? What is the alternative model, and so forth? But the real thing that I want you to take away from this is that students can write books. So if it's not clear how to use a psychological science for effective altruism, just ask the students to help you with this. So I separate them into different chapters. They work on these in teams. And at the end, you have 225 pages of how to do effective altruism through psychological science, which is quite amazing. So honestly, I did not know much about this direction. I wanted to learn this through the students, with the students. And now that I have these books, I was able to learn so much just to see them work collaboratively on delivering this message of impact. We also ran some, giving games from effective altruism in the classroom so that they can see that there's actually real money behind all kinds of decisions of effectiveness regarding charities. So I think for them, this was like a very interesting twist to, at the beginning, doing some open science, but then also having some real impact at the end. So this is kind of like my summary for the whole thing. And I really hope that more places would kind of take what it is that we've done and see this as an inspiration for them to also give some faith, put some faith in their students in order to try to see as a proof of concept whether this is possible or not. And my main message is that as students, as early as second year undergraduates, at least the ones that I tried, are really our most undervalued, underappreciated stakeholder. They're capable of just so much, but we haven't really given them the credit for them to be able to do this. And once you set the path, once you give them the problem, once you give them the tools, some resources to guide them through that, they will deliver at the end. There's no doubt in my mind that we really need to rethink the way that we're doing education, all sorts of challenges, ChatGPT, and all that. No more is multiple choice exam way to train our students. If we want them to have real education, they need to be involved in the scientific process and see what it is that we're actually doing. If you're not sure how to do this, you can adopt our model. So every semester, starting small, adding different components, and then after 5 years, you will get to where we are. But you don't have to follow our steps, because you can just take what it is that we're doing right now. So you have all the resources, you can learn from our experience, you can collaborate with us. So if you want, just like the Brazilian team, take our materials, tell us what you're doing, what you need from us, and we'll work together in order to make this happen in your context, in your educational environment. Everything that I just told you about is shared on my website. You can scan the barcode or go on my name.org at the end. I'm very eager to hear from you and see how together we can make this happen. So you can feel free to, you can follow me on Twitter or the mailing list, but please, if there's something here that's interesting for you and you want to know more about, or something that you're not sure how to implement, and please do contact me by email. I'll do whatever I can in order to support you. If I am too busy or there's something that I don't know, I will connect you with others in the team that might be more suitable for that. But together, I believe that we can make this work anywhere in the world, also in Norway. Thank you.